Alright, hi everyone. So what I'm going to do is I'm going to be reviewing for the Unit 2 exam, okay? So in this video, you're going to see me work a lot of problems from your Unit 2 packet. I'll show you this packet in and out. But yeah, here we go. Just make sure as I'm doing this, you guys are following along. I know even if you've already done it, you're just gonna watch it. No, it's better if you guys do it with me. So that way, even though you did it, you're refreshing yourself on everything that's going on. Okay, so on the test, of course, there's gonna be like definition questions like what is distance, what is displacement, okay? So this is what we're gonna do. We're gonna work on this worksheet, okay, the distance and displacement worksheet. We're gonna do number 2, 3, and 4. All right, so number 2. Anthony walks to the pizza place for lunch. He walks 1 kilometer east, then 1 kilometer south, and then 1 kilometer east again. What was his distance and what was his displacement? So for any of these questions, I want you to definitely draw it. You have to draw it, okay? So let's start with one thing at a time, okay? He walked 1 kilometer east. So 1 kilometer east. Let me move this real quick. All right, so this is east. You're gonna draw, okay, your arrows, 1 kilometer east. Okay, you guys know, right? North, south, okay, east, west. Okay, so here, let me move this down. We'll keep that little compass thing right there. Okay, so 1 kilometer east. Okay, and then it says he went 1 kilometer south. And then he went 1 kilometer east again. So that's how it looks. Okay, what distance did he cover? So we said that distance, right, is just how much ground you cover. So looking at everything that you have done, okay, 1, 1, and 1, all you do is add them together. Okay, so his total distance is 3 kilometers. Simple. Distance is just how much ground you cover. Now, let's move to displacement. All right, displacement. We said it's from your start, so this is where you started. Okay, to finish, which was right here. Now, to find displacement, you have to do a squared plus b squared equal to c squared. Okay, essentially right triangle. So how do we do this? Look, you drew it out, right? But it looks nothing like a right triangle. So you're going to create your right triangle, all right? So if you notice, both of these vectors, they went east, right? So here, let me use a different color so y'all can see it. All right. So here's my start. Boom, 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 boom. So guess what? You went 1 kilometer east here, okay? It stopped right here, he went down, and then he continued east again. So up here, we're going to continue east. So you have 1 kilometer plus 1 kilometer, okay? We know that because he finished off 1 kilometer right here. Okay, so I'm going to start creating my right triangle. I'm going to come down. Okay, we know that this side is 1 kilometer because it said that he went 1 kilometer south. Okay, so here's my a squared, here's my b squared. Okay, and then here is me creating my imaginary line for the hypotenuse, which is my c squared. Okay, anytime you find displacement, most likely you always are going to have to create a right triangle. That's how you use your a squared plus b squared equals to c squared. Alright, so now plug into your equation. A squared plus b squared equals c squared. My a is my shortest side. Alright, that's 1 squared plus b squared, so b squared is my longer side. 1 plus 1 is 2. Here I have 2 squared is equal to c squared. Okay, now 1 squared is 1, 2 squared is 4, c squared, so you have 5 is equal to c squared. Okay, of course it's squared, we're trying to find c by itself. Okay, so this is your a side. I don't know why I put squared, but here's your b side. Here is your c side. You're finding the displacement, the distance from your start to your finish, okay? So, since this is squared, to get rid of the squared, you have to square root it. Square root. Okay? So, plug into your calculator. Second square root, 5. My c is equal to 2.2. Okay? Don't forget your units. So in this case, it's kilometers. I didn't ask you to convert to meters or anything. So your answer would be 2.2 kilometers for displacement. That is your answer here. That is your answer for distance. Okay, so we're gonna do 3 and 4. They're very similar to number 2. Okay, that is it. So let me erase this, and we're gonna move on to number 3. Okay, hopefully you guys are understanding a little bit better as you watch these videos. Not a lot of people are watching these videos, so they're struggling. Not saying that, you know, everybody that doesn't watch it is struggling, but most of the students that have been messaging me on help and how to raise their grade, they actually haven't watched the video. So it is a huge benefit for you to watch this video. Make sure you're paying attention and following along to the questions that I'm doing. Okay. You might not see them again, but make sure you're paying attention, watching, know what is going on. Okay. Honestly, I am just going to do number 3. Just make sure you also know how to do number 4. Okay, so number 2, 3, and 4 on that distance and displacement worksheet. Okay, so we just got done with 2. Okay, let's go to number 3. On his fishing trip, Justin rides in a boat 12 kilometers south. Okay, the fish aren't biting, so they go 4 kilometers west. They then follow a school of fish 1 kilometer north. What is their distance? What is their displacement? So, draw. You have to draw. Okay? So, draw my arrow. He goes south 12 kilometers. the fish aren't biting, so then he goes west 4. Okay, so let's say that's 4. Okay. Then they follow a school of fish 1 kilometer just north. So from there, we can say that's 1. Okay, what is their distance they covered? Alright, remember, distance is just how much ground you cover again. So 12 plus 4 plus 1, 16 plus 1 is 17. Oops. It's not meters, it is kilometers. Okay, 17. Displacement. Okay. Remember, same thing, a squared plus b squared equals c squared. Okay, the c squared is out of the picture a little bit, but it's okay. You kind of get what is going on. A squared plus b squared equals c squared. Alright. So, create your right triangle. Okay? So here's your start. Here's your finish. Now, I'm trying to get this distance here. My displacement, start to finish. The shortest route. Okay, you notice you already have your C. You drew that. Now, how can you create a right triangle? Well, ta-da, look at where you finished. That goes across. That is your 4 kilometers. Okay, that's your 4. Okay, you notice this whole vector is 12, right? But we said that he followed a school of fish, okay, 1 kilometer north. So if you're looking at this picture, all you have to do is subtract 1 from this 12. So that means this side, right here, is 11 kilometers because we subtracted 1, okay, for this area right here. This area, okay, is equal, this area is equal to that 1 kilometer we subtracted, okay? So, you have your A, you have your B. Okay, so A squared plus B squared equals C squared. My A is 4. My B squared is 11. My B is 11, and then my C squared. Okay, 16 plus 121 is equal to C squared. Add 16 and 121, you get 137. C squared. Same thing, to get rid of your squared up here, you have to square root, put it into your calculator. Second squared 137. So my C is going to be 11.7 kilometers. Don't forget your units, okay? Units. Okay, so my displacement is equal to 11.7 kilometers. Okay, ta-da! And my distance was 17. So, hopefully you guys are not confused. If you are, just replay it back. Try to understand what I did. Okay. Now, so I told you, distance displacement worksheet. Okay. Practice number 2 to 4. Okay, that gives you the best practice because it works on both distance and displacement. It works on you guys having to create this right triangle. Okay. So we're gonna move on. Erase. By the way, guys, so next week on Tuesday, you guys have open house at Taylor. Basically, you know, meet the teacher type of night. I'm gonna try to be there if I can, so then y'all can get extra credit points. Hopefully they'll let me be there, because when you're out for maternity leave, apparently you're not supposed to be on any school grounds at all. So we will see. But I am, for those that do go, I'm gonna give you guys extra credit points. Of course, I kind of already put it on Schoology where you have to upload a picture of you, your parent, with a physics teacher, like any one of the physics teachers. That way I know that you guys were actually there. Not that I don't trust you, it's just, you know, some people love to lie. Not saying that you do, but just putting it out there. Okay. So distance displacement worksheet numbers 2 to 4 will give you the best practice. Okay, like I said, there are definition questions. So for your notes, for let me bring it up closer. For scalars and vectors, okay, know what a scalar is, know what a vector is. All right. Definitely gotta know resultant vectors. Okay, add or subtract them. Remember, you can go back to my videos where I talk about them separately, okay, to get a good review on them. So for that one, we're gonna go down. So if you turn the page, you have the check for understanding page. Okay, it looks like this. Okay, we're gonna work on examples for number 2 right here. Sorry. So number 2, okay, we're gonna work on A, B, C, and E. So, looking at your paper, okay, you have A, and it tells you, so vector A, okay, is equal to 8 kilometers east. And then you have vector B, okay, that is equal to 13 kilometers east. You have to give me the resultant vector, okay? All of these are resultant vectors. So whether you add or subtract them, what's the answer? How are they gonna look? So if you notice, these are both going east, okay? If you do it like a graph, okay? If you remember in math class, you have graph, okay? This is positive, okay? Going down is negative. Anytime you go up is positive. I guess I should put my positive over here so it doesn't confuse you. But here's my positive. If you go east, it's positive. If you go south, it's negative. If you go west, it's negative. Okay? It's just like graphing. So they both are going east. Okay? So it's gonna look like this. One vector is 8 kilometers. The other vector is 13 kilometers. What is your resultant vector? 8 plus 13 is what? 21? 8. Yeah, so 21 kilometers. You have to tell me what direction it's going. It's going to be east. And that is how my vector is going to look. Make sure anytime you get tested over like resultant vectors, you pay attention to, you know, the direction, okay? You pay attention to which direction the vector is drawn in. Okay, so that was A. Let's do B. Okay. The vector H is going positive 16 meters. And then vector K is going negative 10 meters. Resultant vectors. I don't really care how you draw this as long as it's in the right direction. So we'll stick to the east and west just because it's easier for me. So we know that when you go east it's positive, so this is 16. Okay, it says positive 16. So I went positive 16 meters. Now it tells you for vector k, it went negative 10 meters. So guess what? If I'm going east here, and that's positive, that means my negative is going to be west. And that is 10 meters. Okay? So what is your resultant vector? We went from there to here. And now, what is our resultant vector? It is going to be, so remember, they go opposite directions, so you subtract. It's going to be 6 meters. I know that much. And then it's going to go into the direction where, of course, the number is larger. Ta-da! That's your A and B. Okay, I think that covers that pretty well. Okay, same direction you add, opposite directions you subtract. Okay, that was A and B. C you can also figure out, so I'm not gonna do C. But let's go ahead and do E. Okay, let me erase this. Sorry if I'm shaking the camera, guys. Okay, you have E. You have vector X going 6 meters east. Vector Y 10 meters west. And then you have vector Z, where it is 14 meters east. Okay, so alphabetical order, okay? 6. I went west. 10. Okay. And east 14. So opposite directions subtract. Correct? Yes. So you have 6 minus 10. Okay, that is equal to negative 4. That just means that it's already, okay. Draw your vector, so it's 4 meters, and now you know that it's going this way because it was a negative. It's a negative number. Okay. Whatever the side it's going is the side you'll draw the arrow in. So now you're left with 4 meters. Okay, going west. Now finish off the rest. You have 14 meters. Still opposite directions. So what is your resultant vector? You're left with 10 meters. Going which direction? We're going east. Okay, positive. So that is E. Okay. So worksheet. Just look over, study A, B, C, and E. Okay, that's in your checking for understanding under scalar and vectors. I'm sorry guys if this video is gonna be long, but I'm just doing it all at one time. Don't want to make multiple videos and upload a whole bunch of multiple videos. Okay. Next one. Next worksheet you have is scalar and vector worksheet. That's what it looks like. We're gonna do number 3, part A and B. Okay. So I'll put it out here for the y'all. Okay. Number 3, a jogger runs 300 meters due west and then turns and runs 500 meters due south. What is the distance she ran, and what is her displacement? So it's kind of really similar to the ones that we did for distance and displacement worksheet. Okay, so draw everything. Like I said, draw. Okay, so start off, she ran 300 meters due west, 300 meters. Okay, and then she turns and runs south. Ooh, yay, 500 meters. Okay, what is her distance? Remember, we said distance is just how much ground you cover, so 300 plus 500, I get 800 meters. Woohoo! Okay, now we're gonna find displacement. Okay, displacement is equal to a squared plus b squared is equal to c squared. Okay, remember, start to finish, your shortest distance. Okay, so a squared, a side, b side, c side. Okay, a squared plus b squared is equal to c squared. My a is 300 plus 500. Sorry, I need to put them squares, equal to c squared. Alright, 300 squared plus your 500 squared equal to your c squared. Okay, so add them both up. $340,000, right? Yeah, 340,000 is equal to your c squared. Remember, get rid of the squared, use square root. To get c by itself, square root. 340,000, put it into your calculator. So you should get 583. So you get 0.09, we're gonna round it 0.1, okay, meters. That is my displacement. Displacement. That is what I get. Okay, and here's my distance. So, really, this is a review because we just did it at the very beginning. Okay, displacement, a squared plus b squared equals c squared. Right triangle, you're always trying to create that right triangle. Okay, so that was number 3. You're gonna turn the page, okay, and we're gonna do number 4 on the back side. I know it's a long video, guys. Where am I at right now? Like 29 minutes. Yeah, crazy. But think about it. I've been talking for 29 minutes. Okay. So number 4. 2 ropes are attached to a heavy object. The ropes are given 2 strong physics students with instructions for each to pull 1,000 newtons of force. Determine the resultant force for the 2 students, okay? So situation A. 2 students pull in the same direction. So here is my heavy object. Okay. They pull in the same direction. So my heavy object, here's one kid. Sorry if you hear my son, guys. Let me see. Okay. They pull in the same direction. So boom, boom, boom. Okay. Pull this way, 1,000 newtons. This one pulls this way, 1,000 newtons. Okay. They're going the same direction. Guess what my resultant vector is? It's going to pull in that same direction. Add them up because they're pulling the same direction. It's going to pull 2,000 newtons. That is your resultant vector. Okay. Situation B. Let me see. Give me 1 second. Okay. So, situation A, situation B. Sorry you had to hear my baby cry. Okay, my bad. Alright. Situation B. Same thing. You have your heavy object. Okay. You have your heavy object. I don't know if we need more room. I'm gonna draw it right here. So here's my heavy object again. Okay, now the kids are pulling in opposite directions. So I'm gonna draw one kid here. Draw the other kid here over here. Alright. Here's the string. Here is the string. They're pulling in opposite directions. So remember, every time I pull, it's gonna be 1,000 newtons. 1,000. Oops. Newtons. Guess what? Because they're going in opposite directions, what is my resultant vector? 0. Okay, so it's gonna be 0 newtons. It's like the word on. So 0 newtons. Situation C. At right angle. So one of them is going to pull south and the other one is going to pull east. So here's my resultant vector again. Not my resultant, my heavy object. Okay, one is pulling south. So I'm going to draw one guy down here. Okay, one is pulling east. So I'm going to draw the other guy over here. Pull, pull. Oh, guess what? I created a right triangle. Okay. So, this guy pulled 1,000. This guy pulled 1,000. A, B, doesn't matter which one you make them. Plus B squared equals C squared. You have 1,000 plus 1,000 squared plus 1,000 squared is equal to C squared. Okay. So 1,000 squared plus 1,000 squared, just put it into your calculator. You get 2 million. That's equal to your C squared. Remember, get rid of the square, square root of C. It's going to be 1414.2 newtons. Okay, that is your answer for C, for your resultant. Okay. So moving on. We're gonna go into our speed and velocity notes. Okay, same thing, make sure you know the definitions. Alright, the video's already, what, 35 minutes? I don't want to take up more of your time. Just know, pay attention to, for this one, question 3 and question 4. They're not hard. They're pretty easy. You guys just have to take your time to do them. If anything, I'll have a separate video on how to do number 3 and 4. Alright. Most likely, I'll have a video on 3 and 4. You will see a question like 3 and 4 on the test. Okay, just make sure you know how to do it. You pay attention to it. Alright, that is it.